Hello there. How do we handle triangles when Torcaso fails to answer the call? Yes, in this video, we're going to solve the impossible. We are going to master the sine rule. So stay connected till the end. What is sine rule? In the next slide, I will show you how we can derive the sine rule. Let's start with a triangle where I'm going to label it as triangle ABC. Right, so in these derivations, I'm going to assume that you know how to use half AB sine C to find the area of this triangle. And what is half AB sine C? And that it's, we're going to label the sides that's opposite angle A as lowercase a, the side that's opposite angle C as lowercase c, and the side opposite angle B as lowercase b. So the area of triangle ABC can be found by using half times A times B times sine angle C. Or we can find using half times A times C times angle B, or half times half times B times C times sine angle A. Right, so all these three formulas are equivalent to one another. And we're going to do some magic here. And what is it that we're going to do? We're going to divide it by half ABC. And with that, we can do some cancellation. The half and the half can goes off. The A and the A can goes off. The B and the B can goes off. The C and the C can goes off. The B and the B here, and the C and the C here. All right, so what is remaining is the ratio where we take sine of the angle C over C. That ratio is equals to sine of this angle B over the sides B equals to sine of the angle A over the side A. And basically, this is the sine rule. And how do we use it? I'm going to show it in the next slide. All right, let's look at these questions. We're given a obtuse angle triangle IGH. Why is this the obtuse angle triangle? Because the angle IGH is 118 degrees, which is more than 90 degrees. So that classified it as an obtuse angle triangle. And we're asked to find the unknown angle. So basically, this angle IHG and also the sides GH and IH. All right, so let's start off by finding the angle IHG, which is just using 180 degrees to minus 24 minus 118. So that gives you 38 degrees. So this angle here is 38 degrees. Right, so how do we use the sine rule? Right, so we draw arrow. So how do you draw arrow? It's very easy. Right, so let's start off with 118. You just draw an arrow that points to the sides that's opposite 118. It's just like, imagine you are standing at 118 and your friend is standing opposite you. All right, so the sides that's opposite angle 118 will be IH, and the sides that's opposite 38 will be the 8 millimeter, and the side that is opposite 24 degrees will be GH. Okay, so we're going to find GH. Right, so we're going to use GH to the ratio GH over sine. Okay, let's do a recap of your sine rule. So your sine rule is actually sine angle 8 over the sides A equals to sine angle B over B equals to sine angle C over C. Right, but you can also do it the other way around because we are actually just comparing ratio. All right, so it's possible to find the ratio for sides over the sine of the angle equals to sine over the sine of the other angle, so on and so forth, okay? Because they're just comparing ratio, so that it's all right, okay, to do it sine A over A or A over sine A. All right, so in this case here, your GH is opposite angle 24. So GH over sine 24 and equals to 8. 8 is facing angle 38. So 8 over sine 38. So these two ratios are the same. All right. So the next thing is that we do a cross multiply. Right. So if you do a cross multiply, you will have GH times sine 38 degrees equals to 8 times sine 24 degrees. So to find GH, you just divide by sine 38 on both sides. So that explains this part here. And you just basically use a calculator. All right, but express your in-between answer to 4 significant figure. Final answer, then put it to 3 significant figure. So that's for GH. So we still need to find the side IH. All right, so the next thing is IH is facing the angle 118. Okay, so you can use 8 over sine 38, or you can use GH over sine 24. But of course, using 8 over sine 38 is a better choice because your IG, the 8 is actually an exact value. You wouldn't want to use 5.285, non-exact. Okay, right, again, we do a cross multiply, okay, and then you make HI the subject. All right, you use a calculator, and then you will get 11.5 millimeter for HI. Right, let's look at the next questions. Next questions, we're given a triangle ABN, also BND and BCD. So basically, there are 3 different triangles down there, and there are 2 right angle triangles there, ABN and BND. All right, and we're asked to find the length of the metal bar AB. All right, so let's focus on this triangle here, triangle ABN. So since triangle ABN is a right angle triangle, we can usually just use Picasso. Right, so we can just opposite 25, BN is the side opposite 25, so that is your OPP. And the side that's opposite 90 degrees is your hypo. All right, so we OH, so under Picasso OH, so that is under so. If you were to recall Picasso, right? So under so you have O, you have H, so we can just use sine. So sine 25 is equals to the opposite side, which is your B end, which is given to be 5.3, then over the hypo AB. So AB is the side that you're finding. All right, so we just do a cross multiply. So sine 25, you can write it as sine 25 over 1, just do a cross multiply. So you will have AB times sine 25 equals to 5.3 times 1. Then you divide by sine 25 on both sides. So AB is 5.3 over sine 25. Right, so does it mean that we can't use sine rule in the right angle triangle? No, you can actually use sine rule. So how do you use sine rule in the right angle triangle? Okay, so yeah, since we're finding the sides AB, so AB is opposite 90 degrees, right? So AB over sine 90 is equals, and since we're given 25 and the side that's opposite 25 is 5.3, so that will gives you 5.3 over sine 25. All right. Okay, so we do a cross multiply. We have AB times sine 25 equals to sine 90 times 5.3. And what exactly is sine 90? Sine 90 is actually 1. So 1 times 5.3 is just 5.3. And to find AB, you just divide by sine 25 on both sides. So which is what we have it here. Whatever you get here, star, star, can you see? It tallies. Right. So sine rule is very versatile. You can use it in a right angle triangle, also in a not right angle triangle. Okay, but for Picasso, definitely you can only use it in a right angle triangle. Okay, so that's how we do part I. All right, so to do part 2 is to find the angle that BD makes with BN. So basically, which angle are we referring to? So the angle that we're referring to is this angle here. Okay, again, this one happened to be in the right angle triangle, BND. So you can use Torcaso or you can use the sine rule. All right, so here I'll prefer to use Torcaso. So in triangle NBD, all right, we use cosine. So if this is the angle we're interested in, this will be my opposite side. And BD, it's a hypo. So that makes BN the adjacent side. Okay, so you know A and you asked to find, oh, you know A and you also know H. So that's car, right? Under Torcaso, that's car AH. So cosine angle NBD is 5.3 over 7.1. All right, so NBD will be cosine inverse that, and that's how we get the angle for the 1.7 degree. Okay, let's look at part 3. So for part 3, find the length of the metal bar CD. All right, so in this case here, then, all right, then we have to use the sine rule. Okay, so we can see that BCD, it's not a right angle triangle. Okay, so we have to use the sine rule. So this angle that's opposite side BD, it's 103. Okay, and then yeah, and we know BD to be 7.1. So the angle that's opposite 7.1 would be this angle here, BCD, which we can find by using 180 minus 103 minus 46. Okay, and then you can just apply your sine rule. CD over sine 103 equals to 7.1 over sine 31. Just do a cross multiply again, and then make CD the subject. Right, so that's how you get CD to be 13.4. Let's look at the next question. In this question here, we have 3 triangles, PQS, PRS, and PST. PRS and PST are right angle triangle. Right, in part I, we're asked to determine if QS is parallel to PT. So what we're going to do is that we're going to find this angle here, this angle SPT. We're going to see if it's equal to 54. If it's equal to 54, then we can use the alternate angle property. The alternate angle property. If both of those angles are equal, then we can say that the line QS is parallel to PT using alternate angle property. Right. So to find angle SPT, since triangle SPT is the right angle triangle, we can use Torcaso. You can go ahead and use sine rule, so no problem. Right. So the angle, the side that's opposite the angle SPT, it's 5.7. So that is your opposite side. And then the one that's opposite 90, it's your hypo. So the remaining side PS will be your adjacent. Right. So you know A and you know O. So we can use TOA, tangent, right, to find the angle SPT. All right, and we found SPT to be 52.97. Right, so we can do our conclusion now. So since angle QSP, because QSP is 54 degrees, is not equal to SPT, right? We can't use alternate angles property. Hence, QS is not parallel to PT. Let's look at how we can do part 2. Find the length of PR. Right, so we can use triangle PRS, and PRS, it's a right angle triangle. Right, so we can find angle PRS first by using 180, take away 63, take away 90, because this angle here is 90. So that gives PRS 27, right? And we can use, let's see which one we can use, sine, tangent, or cosine. Right, so we can decide that's opposite 27 will be your PS, which is 4.3. So PR is the one that's opposite the 90 degrees. So that is your hypo. Right, so OH, so we can use sine. So sine 27 will be equals to 4.3 over PR. Right, and we can write sine 27 as sine 27 over 1. Can just do a cross multiply. So PR will be 4.3 divided by sine 27. and that gives you 9.47 centimeter. Right, so the next part of the question, we are asked to find the length of QS. So in this case here, we have to use triangle PQS, and PQS is not a right angle triangle anymore, so therefore we have to use the sine rule. All right, so we can go ahead to find angle PQS first to get 63. And then what do we realize here? Yes, angle PQS is 63. It goes to show that triangle QPS is an isosceles triangle. So therefore QS is equals to PS equals to 4.3. Right. Since triangle PQS is an isosceles triangle. Right, let's look at the last question. In these last questions, we have 3 buildings on the plot of land form a triangle M and O. So the buildings M and O are the furthest apart with a distance of 80 meter, and building N is 67 meter away from building M. It is given that angle MON is 43 degrees. Find the distance between buildings O and N. All right, so the first part of the questions, we're going to find angle O and M first. Right, using sine rule. So sine, the sides that's opposite angle M and O will be MO. Right, so sine angle O and M over 80 equals to sine 43 over 67. Let's do a cross multiply. Right, and divide by 67 on both sides. So to find angle OMM, you just sine inverse the right hand side value, and you get 54.52 degrees. Because this is not the final answer, you should leave it as to 2 decimal places. All right, so how is O and M helping us to find the distance between O and N? All right, look at the diagram carefully. O and M is actually an obtuse angle, okay? Because it's opposite the longer side, MO. The longer side is MO 80 meter. So therefore, M and O should be an obtuse angle. But the answers that you have you have found is actually a cube angle. Right, so how do you get an obtuse angle? Yes, we take 180 degrees minus away of 54.52 to find the obtuse angle O and M. Right, so with that, we can use sine rule again. All right, to find the distance. Oh no, we need to find angle OMN first before we can use sine rule. Right, so we're going to use 180 degrees minus 43 minus 125.48 to find angle OMN. And then with that, we can use sine rule to find ON. Right, so you do a cross multiply. Take 80 times sine 11.52 divided by sine 125.48. And that gives you ON to be 19.6 meter. Okay, so that's all, folks.